Hi everyone, I am Vidhi Chug. I'm glad to have you all join me for the session where I discuss some of the best practices of maintaining high quality data. I am an AI/ML innovation leader and carry a decade of experience in working with data driven solutions. I am passionate about promoting ethical and responsible use of AI and have conducted several workshops explaining and demonstrating how ethics can be embedded in AI powered solutions by design. So, without further ado, let me take you through the agenda for the talk today. We'll briefly discuss what is data governance and why there is a need for the organizations to adopt it. I'll give most of the examples related to data quality from the lens of a data scientist, as that's my background. We'll define what are the quality metrics of data and how the organization can work on maintaining a high quality data. We, will explain what is the need of organizations to adopt data culture organization wide, how owning the data is the solution to all problems related to data. Towards the end of the talk, I'll conclude with some of the best practices that we can adopt to make sure that we are working with good quality data. So we'll get started. Data governance framework. So it's a collaborative model that involves multiple stakeholders to come together and decide what data is needed, what would be the objective of that data, where it would be used, what all transformations are we planning to perform on the data, and what would be its impact. In short, if I have to put it, data governance is all things data. So all organizations are working with humongous amount of data and are in need of a framework with which they can properly use and work with quality data that acts as an enabler for their business metrics. So, should everyone try to work scratch up or reinvent the wheel? No, that's not needed. That's precisely what these frameworks are for. That includes having templates, models, and best practices that other organizations are using so that every organization can overlay their specific data needs on top of these framework. I call it as adopt and adapt. So adopt the given framework and adapt it according to your organization need for the data. Like I mentioned in the beginning of the call, I'll keep giving examples and analogies from the ML machine learning project lifecycle. Similarly, in long-term investment, data governance, uh, the long-term investment part of data governance is similar to machine learning project lifecycle. When a project starts, we need to understand the objective of an ML project, where the data will come from, what all data is being made available, to what feature engineering will we do on the data, to all the way to working with the candidate models and selecting the one that will go to the production. This is an entirely rigorous process, but it just doesn't end here. The time the model makes to production, model monitoring and maintenance is another charter in itself. Similarly, when we design data governance, we decide the processes that would be followed and we lay down the groundwork. But it just doesn't end here. It's not a typical project which has a certain timeline to deliver, it's an ongoing effort. You can't just do it once and wrap it up. It has to be a part of your organization culture. Data governance works with people, process, and technology at its center. It solely relies on the people with the right skill set who can endorse the process and promote and embed it in the technology. What are the best practices of adopting data governance frameworks? Like in an ML project, you start with a proof of concept. Similarly, for data governance, you need to start small. You need to have a team with well defined roles and responsibilities so that we can measure the progress towards the roadmap and gauge the benefits of the framework. What benefit will it yield to us? Like, you just don't need it to analyze it for yourself. When you start small, You understand what worked and what did not work, so that later when you expand it and take it to rest of the organization, you can take those knowledge that you've learned during the small project across the organization. Similarly, when you need to sponsor and you need to get the leadership sponsorship on data governance framework, you just can't simply say that we are dealing with bad quality data and this will act as an enabler for us to move towards improved quality of data. So everyone knows that it's a hindrance or impeding their business metrics, but you need to prove it how. For example, if we explain that the move from improving the data quality will lead to, for example, if it has to be machine learning project, we can explain that it's going to yield a better trained machine learning model, which in turn will give better inferences with higher degree of confidence. What do we do those? What do we do with those predictions? Maybe we are able to understand the customer behavior better, the changing demands of the customer, the dynamic nature of their requirements. These in turn lead to better customer retention, and that can be directly correlated with business revenue. Not only this, it also yields operational efficiencies as well. This kind of proposal will definitely get you a buy in from the leaders. Next is assess baseline and evaluate the gaps. Similarly, in ML project, when we start, we need to understand if there are human expert or a set of heuristics that are currently carrying out that process, and if they exist, what is it that they are achieving best. We need this number simply because this acts as a baseline for us, which we definitely want to improve upon from, to understand the value of the new process we are bringing in. Similarly, for data governance, we need to understand how are our current data processes look like, how far we are from the goal. This gap identification is the window to opportunity and size the impact that the new processes can bring in. We need to periodically measure the metrics which are defining our goal and communicate it to the stakeholders at certain checkpoints to make sure that if there are any bottlenecks, we can all collaborate together and find a better solution. The last and the most important thing on this slide is roles and responsibilities. Typically, when we enter into a meeting, it looks like everyone is engaged, but what we want is more than that. We want active engagement, defined roles, and the ownership of their responsibilities. I'll take you through the next slide where I've tried to capture the general responsibilities in an organization. It may differ from one organization to another. For example, Data Governance Council is responsible for prioritizing the projects and approving the policies and processes that are laid down by governance board. Data managers take these processes and put them into database system to meet the organization's data needs. Data owners are accountable for their data assets, while data stewards look for data quality and integrity. Data users ultimately use this data for statistical and research purposes. Data and its science. There are a lot of organizations that are trying to get a competitive edge by putting AI powered solutions in the market. No, it's known fact that there are a lot of state of the art cutting edge algorithms available. Now, the organizations also have the flexibility of increased compute power and they can manage the data at scale. So, gone are the days when data used to be a distinguishing factor. These days, most of the organizations have enormous amount of data to work on. The question is, do they have quality data to get a competitive edge? It looks very easy here, but it's not all hunky dory because, as per the report here, bad data can cost a business 15 to 20% of its revenue. But why would that happen? Because data might be coming from multiple sources. What we want is a unified view of the data for us to get actionable insights and improve the business metrics. This integration is the critical part in which business domain experts and subject matter experts are needed to convey the necessary logic. How they convey the logic versus how it is interpreted by the developer could be a big gap. What the developer has understood versus what they actually go and implement needs to be well aligned with what subject matter experts have highlighted. These intricacies can make the data come out bad if it is not encoded properly. You must have heard a lot of data scientists say our ML model could do best to what data it has seen during the training time. This is indeed true. If the machine learning algorithm gets to see a garbage data or the buggy data, it will throw out the predictions which won't make sense. But if we have to understand the pain the team goes through while they're working with the bad quality data, think of data science as iterative by nature inherently. They are already repeating multiple experiments. Now, if they have to repeat an experiment simply because the first experiments or the initial experiments that they've done were using buggy data, and that does not make sense. It not only just leads to waste of resources but demotivates the team as well. We also need to make sure that the data is kept secure and there are no unnecessary or unwanted edits being made to the data, and to make sure that we are complying with the regulatory requirements. By now, given the examples of data governance and machine learning projects, we know data quality is itself is also not something which you can do once and let it be free. You have to iterate upon the data quality metrics and the checklist to make sure that you continue working with good data. But we just don't want that. We want beyond that. For example, we want proactive measurement rather than when everything has been happened and we are trying to do the damage control. Think of an example where data science team is one of the consumers of this data. They consume the data, train the model, and the model would have learned from the bad data. And when we try to make predictions based on such models, after the error analysis, only does the team gets to know that there were some bugs in the data. If they get back with that and attribute it to data quality, a lot of time has passed since then. We really don't want to end up into that state where we are trying to pick up from the consumers of the data that the data did not make sense or they cannot act or consume this data anymore. We want to be proactive. And to be that, we need to make sure that we are detecting it early and putting those checks as close to the source of the data as possible. We also need to work with data stewards who are responsible for maintaining the data quality and integrity. And all of this gets summarized when the organization is willing to adopt data as a culture. In the end, we need to make sure that it's not just having the data that is informative enough. To be able to gather enough information from the data, we need to make sure that we are working with good quality data. I have captured five metrics to define good quality data here. I'll give you an example of each of these. Completeness. The data should be complete. By any means, if your data does not capture any entity, for example, if it's about the end users, it could be coming from a particular gender, race, or color, then your data is biased towards rest of the users and would not be able to perform good on certain group of users. This could lead to biased results and in turn could cause ethical considerations. Reliable. Is your data reliable enough? Can you trust your data to take business mission critical actions? Next is accuracy. You need to have certain measures with which you define how accurate or good is your data. Consistency. The data needs to be consistent throughout. I'll give you an example. If we talk about an item in one data versus item in another data table, it could be that the name of the attribute is same, but they are essentially talking about two different items. You must be thinking, how is that possible? It is. In a supply chain, you might be talking about raw material as item at one point in time, but when that item gets processed and there are some operations done on that raw item, it goes into the work in progress, or maybe semi-finished goods. So that's another item from coming from dataset 2. Third example could be the finished good or product altogether. So this third item also could be labeled as item, but would be meaning a different product. So when you have three such data sets, you need to know the right definition of item coming from each data. Without knowing that, if you try to merge these three data sets, your joins will be done in a wrong manner. So we need to have a single ground truth and data definitions of each of the attributes. And make sure that I'm trying to give all these examples purely right now from the perspective of how we would want data for data science teams to consume. Next is timely. So you want to make sure that you are not working with stale data, especially in e-commerce and some other industries. Data changes very dynamically, and you want to make sure that you are giving constant updates to the data and you are working with fresh data as much as possible. So far, we have understood the importance of why organizations should have a focus on adopting data culture. But unfortunately, it is not yet there. Data is still not the priority for a lot of organizations. You can get an example by this study, which says that 47% of the new data includes at least one critical attribute that is having error. How could that be possible? Because data, like I mentioned before, is coming from different streams. And when we put a process of automation on that to try and integrate the data to be able to make some sense out of it, there could be a lot of things that can go wrong there. So we need to possibly identify failures as early as possible and define the metrics to cover the data quality reports. As also explained before, when we were talking about consistency of data quality metrics, having a single source of truth is very critical, and all of these actions come under governance and continuous auditing. Trustworthy AI solutions can only be worked upon if they have been trained on trustworthy data. We need to make sure all the data transformations that we are doing, they are in the right format. The outliers are detected correctly, but for that we need to clearly identify and document what does it mean to have an outlier in one data set, or the definition can change altogether when we take it to another use case. Do we understand why the values are missing? Is it a systemic error or something which is erred while doing a human entry? Or is it leading to missing value for a particular group of people altogether? Are all the records that we are seeing in the data are unique? Or if it is coming from the integration of multiple data sets, then we need to go back and check those merge and joins as well. There are myriad ways that the data can go wrong, and these act as silent killers, specifically when they are fed to data science or machine learning algorithms. But what damage can they do? It's something is bad, we can always go and correct it, right? But it's not really the case. There are some impacts for which we need to which lead to waste of resources. If you act on taking some actions based on those analysis, your business strategies are scraped. The insights coming out of those data are useless for you. You can't act on them anymore. So it's a net loss for the organization. Now think of the case when we have already wasted so much time because we worked on bad data and continued working on it without trying to improve it. Now same time could have been used in a much judicious or prudent manner when while we could have spent it on the data early on, right in the beginning. One way I think we can do, at least from data science perspective, is to have tier-wise critical attributes. In an example that I shared before, where 47% of the new data had at least one attribute which was critical and was wrongly populated, we can have tier 1, 2, and 3, where tier 1 would be highly critical attributes which are important for the algorithm to give the right predictions. And we can put a threshold saying that for this particular tier attributes, I want the data quality to be as high as possible, maybe 95% and above. Tier 2 could be something without which the algorithm can still go ahead with a reasonable degree of confidence and give predictions. Those could be given a threshold of 90%. And there are tier 3 attributes which may not be necessarily used or consumed by DS1 but are still used for other consumers. We can say 85% and above. But at least knowing where do we stand with respect to data quality is important for all the consumers to be able to trust that data and consume that data for some actions. So at the end of it, if I ask you, do you trust your data? What would your answer be? Owning the data. Who will actually own the data? Would it be business or IT? This is a perpetual question, but the answer would always be one. Business has to be responsible for what they expect from their data or whatever objective they want to meet for the business. In what form and shape do they expect the data to be made available? So, in other words, business should own the data. We need business and domain expertise in small issues as much as possible to even declare an outlier. The definition of outlier is also where we need domain expertise. Whether we are getting the data in the right format or schema, or the data distribution has changed than what we were expecting, we need to profile all these values. Decisions also need to be taken about, can we let the incoming bad data, like if you publish the data quality report and it does not qualify to be a good data, would you still let it go to your database, or would you pause it? Should you stop serving it till you resolve the data? Would you mind having a soft or a hard constraints that you can later work on? But while you do all this, you need to be aware of one thing which is called as rule of 10. What it says is, if you get a bad quality data, the time it takes you to fix that issue is 10 times the time that you would have spent had it been available in perfect form. So you need to investigate, do define your errors. How would you detect the errors? Where to identify? What all possible errors can occur? And what would be your plan of action on them? All of this comes as part of owning your data. We have reached towards the end where I'll conclude the talk with some of the best practices, and I've categorized it into four sections. First is defining the metrics without which we cannot talk about how far we have come in terms of improving our data quality. Are we getting it in the right format? Have we detected outliers correctly? Whatever errors we are encountering, are those systemic or some issues are there in the data collection? Has the distribution changed significantly? Are there a lot of nulls that we've started observing lately as compared to the time series historical data of those attributes? Capturing this report is important. Next is documentation. The data, like I mentioned, is coming from different input streams, and there are a lot of stakeholders who are involved and collaborating on this effort. So, documenting each assumption and how this data has been maintained is very important for everyone to be on the same page. The business logics that have been embedded should also be clearly called out, as well as the current checks that are being performed to make sure that everything is adding up and is consistent. Third is owning your data. Who will own the data? Generally, data analysts and data scientists in a machine learning solution, they are supposed to give the insights, which gets consumed upstream. But you must have heard certain executives saying that these numbers don't add up. In my experience or the history of experience, I've not seen such numbers. Where is this coming from? This wisdom is coming from their years of experience, called as intuition as well. So we want to make sure that all who are consuming that data should be equally qualified to call out the issue. And if it requires them to be getting through a certain training program, then that should be done as well. Fourth is audit. We should make sure that any new data that is coming into our database, should be vetted properly. There should be quality assurance to make sure that we are not letting any bad quality data pass by, as it saves our time and resources if done in a timely manner. So with this, I've come towards end of the talk. I hope I was able to convey some of the best practices that I have followed and are some that are prevalent in the industry. If you have any questions, please feel free to reach out to me via LinkedIn. I'll be happy to answer those. Thank you and have a great event ahead.